in last class, when we talk about last class, we have studied the basic parameters, right, involved with gases, right, which is pressure, how pressure is measured. Then it is measured by an instrument called as barometer. Now there's another instrument called manometer. Okay, right? There's another instrument called manometer, but we will study it in last because it is not in your JEE or NEET syllabus. Okay, right? It's not used widely, right? So we will study that at the end of the chapter. Okay, then apart from that, we studied Boyle's law, right? All of you remember Boyle's law? Tell me, all of you remember Boyle's law? Have you gone through the notes as well as the lecture? Yes, right? Everyone remember? So Boyle's law relates pressure with volume. Pressure of the gas, pressure exerted on the gas, and the volume occupied by the gas. And they state that pressure is inversely proportional to volume, keeping temperature and number of moles of gas constant, right? That is your Boyle's law, as simple as that. We have discussed the different drafts of Boyle's law. Okay, the second law is Charles law. So obviously these are the name of the scientists, right? Boyles and Charles. They have given the law. That's why we have to remember the name. Okay. Now, first question that we should ask, that this Charles law relate which two parameters? Which two parameters, right? So this Charles law will relate volume and temperature. Okay. It will relate volume occupied by the gas and the temperature of the gas. Now just think about this. Just think about this. If you heat a gas, what will happen? Tell me. If you heat a gas, right? If you increase the temperature of the gas, what will happen? Tell me. Anyone? You can message. Yes, very good. Wes, Rona, Siddhartha, right? Pranjal, very good. So I can say that if you increase the temperature, the kinetic energy will increase, right? And now we have studied that temperature is actually related with kinetic energy of the molecules. Okay, now if the kinetic energy will increase, then they will try to move faster and expand. Okay, right? They will try to move faster and they'll expand. Okay, and obviously if they expand, the volume occupied by them will also increase. Yes, right? Now keeping that the wall of the container can move, right? That's one thing. Okay, if the wall of container cannot move, then it's your constant volume case. Okay, right? So when we talk about Charles law, there's one thing that we have to remember, that the wall of the container, right, where the gas is kept, is your movable. Got it, everyone? Right? So I can say that, see, yes, closed balloon, it can expand, right? And when you talk about container with lid, which is also called as piston, right? So it can move. Okay, it should move, right? Because if it's a closed container with non-movable walls, okay, then the volume is constant. Doesn't matter what you do, volume will be taken as constant. We will see these cases in problems. Yes, OS. So piston like in series, okay, where the volume can change, right? Okay, so this is the relationship between volume and temperature, and it was given by Charles. That's why it is called as Charles law. So Charles law says that if the temperature of any gas is increased, right, the volume will also increase when the amount of gas is constant and pressure is also constant, right? So obviously the two parameters, which is pressure and number of moles, should be constant in Charles law, right? As in Boyle's law, temperature and number of moles was constant, and in Boyle's law, right, which was P inverse equal to V, right? In this case, pressure and number of moles should be constant. Got it, everyone? Everyone got this? Tell me. Yes? Did you get it? What is Charles' law? This is law which relates volume of the gas and the temperature of the gas, right? And according to this relationship, volume of the gas should be directly proportional to the temperature when pressure and number of moles are constant. Okay, now when you talk about the temperature, when you talk about the temperature, okay, in chemistry, we will always take temperature in Kelvin. Okay, we will always take temperature in Kelvin. Okay, so if you talk about 0 degree centigrade, V is equal to V plus B by 273. ये होता है, ठीक है, right? Now when we talk about V at any temperature T, right? Any temperature T. Okay, this is V plus V T1 by 273, right? And it is at temperature T1, and at temperature T2, it is V2 is equal to V2 plus VT2 by 273. So V1, V2 is actually V0. This is V0, right? Okay, V0. So I can say that if you talk about the change in volume or the ratio, right? If you talk about the ratio, so this is V0, V0. I've already told you this is V0, V0. Okay, there's a fixed volume, which is your molar volume. Yes, all if you remember that molar volume, right? And then when you change the temperature, the volume will change accordingly. Okay, so that's why we have VV. So if you divide V1 by V2, if you divide them, you will get this. If you take the LCM, you will get V. So this is V0, 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 or just VV. So it will be 273 plus T1 by 273. Yes or no? In the same way, this will be V into 273 plus T2 by 273. Tell me, yes or no? Right? Where V or V0 is your initial volume, right? Right? 0 Kelvin, you can consider like that, right? Or your molar volume, that's a fixed volume, right? Then T1 and T2, when the temperature will increase, volume will change. So these are the parameters, right? Which is with change in temperature. So if you take the ratio, this V will get cancelled, 273, 273 will get cancelled. So you will have 273 plus T1 by 273 plus T2, right? Now this T1 and T2 was taken in, tell me, it was taken in degree centigrade. Yes? It was taken in degree centigrade. Now 273 plus temperature in degree centigrade will be temperature in Kelvin. Got it? That's why temperature should always be taken in Kelvin, right? Anyone? Any issue in that? You just have to remember this is the derivation why it should be taken in Kelvin. Okay, right? Anyone have any issues? Tell me. Or you understood everything? Just raise your hand, right? You just have to remember that the ratio of volume should be equal to ratio of temperature, but that temperature should be in Kelvin, not in degree centigrade. Okay, okay? That's what I said now, right? See here T1 and T2, it is written in degree centigrade. See, degree centigrade, for this formula, right? That's why we will get V1 plus, sorry, V1 by V2 is equal to 273 plus T1 by 273 plus T2. Okay, right? Yes, by experiment. Yes, it's by experiment. Whenever we talk about any law, fundamental law, it is from experiment. even the P is inversely proportional to 1 by V, right? Or this relation. Everything we got by experiment. Got it? ठीक है? समझ में आया सबको? है ना? Observe किया गया, then formulate किया गया. ठीक है? In chemistry, everything is first observation, then formulation. Most of the things, right? So that's why 273 plus small t1 is capital T1. Small t1 is in degree centigrade. Capital T1 is in Kelvin. Got it? सबको समझ में आ गया? है ना? So V1 by V2 is equal to T1 by T2, or V1 by T1 is equal to V2 by T2. So this is the relationship between volume and temperature, right? Now when you talk about the graph, right? So yesterday I have told you, if the graph is y is equal to mx, right? It will pass through origin. If we have y is equal to mx plus c, it will be 0. If x is 0, y will be at c. So the graph would be something like this, right? Because x is 0, then y is c, because it's a constant, right? Any issues in that? Tell me, any issue in that? Now, if we have, right, see this is V versus T, right? Now we know that if the temperature scale is in Kelvin, it should start from origin. Yes or no? Tell me. If temperature scale will be in Kelvin, it will start from 0. Yes? Tell me. है ना? Right? But if temperature scale in degree centigrade, then it will start from minus 273, है ना? Because 0 Kelvin is minus 273 degree centigrade. Yes? ठीक है? Right? So in Kelvin, it will be starting from 0 Kelvin. ठीक है? And when you talk about degree centigrade, it will start from minus 273. See it, Hosa? I'll just show you another graph. Okay, it will be much better. Yes. So it will be like this. ठीक है, वो वाला ग्राफ गलत था. ठीक है, because minus 273 है ना, वो पीछे जाएगा, right? Because it's negative, right? So यहाँ पे तो यहाँ पे करेक्शन कर लेना. This is your line. ठीक है, got it everyone? This is your actual line. यहाँ पे 0 है. ठीक है, right? This is 0 here, and this is your minus 273. तो ये लाइन गलत है. ठीक है, got it everyone? Tell me. See, normally देखो, ये डिग्री सेंटीग्रेड की बात करें ना, अभी हमने देखा, right? Just write the equation in degree centigrade. So it was y और डिग्री सेंटीग्रेड का इक्वेशन क्या है? V, ध्यान दो, is equal to V naught T plus 273. Tell me, yes or no? In degree centigrade, this was the equation. Yes or no? Tell me. Yes. So if you rewrite it, V is equal to V naught T plus V naught into 273. Yes or no? Tell me. Yes or no? Yes. Now V0 into 273 is a constant. So equation क्या हो गया? Y is equal to mx plus yes, got it, है ना? समझ में आ रहा है? mx plus c हो गया. Can you hear me? ठीक है? Now, if x is 0, now if x is 0, just think about this. If x is 0, y will be c, na? Right? So if x is 0, y will be c. ठीक है? Right? Got it? और x negative होगा तभी ना y 0 होगा. So x is negative, right? Then y is 0. Got it, everyone? ठीक है, right? So सबको समझ लो. Okay, ठीक है. Everyone, is my voice breaking? Right? Because I can hear myself clearly for now. It breaks for 1-2 seconds, but it's fine for now, for me. Okay, tell me, is it fine? Right? Because it breaks for 1-2 minutes, sorry, 1-2 seconds, right? But it's fine. Okay, just focus. I'll repeat once or twice. Don't worry about that. Okay, right? So this is the graph. If temperature is taken in degree centigrade, remember this, है ना? But when temperature is taken in Kelvin, when temperature is taken in Kelvin, it will be from 0. Got it, everyone? Yes. Tell me. Because the graph of line y is equal to mx is a straight line passing from origin, because x0 then y0. ये क्लास 19 में पढ़ा था, है ना? लीनियर इक्वेशन इन वेरिएबल ग्राफ. Now try to solve this numerical. Everyone, try to solve this numerical. ठीक है? Try करो एक बार. Okay? Try to solve this numerical.